What's up guys, I'm Vinny and welcome to Alavanca.
This video is part of the Explained by Examples series.
Before we get started, I would like us to awake our AI assistant, Mr. V. V, are you there?
Sure, I'm here.
Super cool. So tell me, what is the topic for today?
In today's video, we will be covering one of the creational patterns, the factory method.
What about start with a concept definition?
Why not? The factory method is a creational design pattern which solves the problem of creating product objects without specifying their concrete classes.
So what about some pros and cons?
Pros: removes the instantiation of implementation classes from client, provides approach to code for interface, makes our code more robust, less coupled, and easy to extend, and improves testability of your application. Cons: increases the number of required classes in code. The extension of application requires better design or elaboration, and code can be harder to read at first glance. 3. Use cases. Java provides a variety of, let's call them native classes, with the usage of factory method pattern as such as the util calendar class and the get instance method, the util resource bundle class and the get bundle method, the util enum set class and the auth method, and the text number format class and the get instance method. As for the test automation context and usage, the factory method pattern is widely used to create WebDriver instance based on user input needs such as Chrome, Firefox, Edge, and so on. Cool. Now, we are heading to the coding practice example, and for that reason, let's check the use case that will be used for this exercise. We will start with the shape interface, which will be implemented by the rectangle, square, and circle concrete classes. In order to simulate a client interacting with this model, we will create a shape client app which will play the actor interested into object creation. Right after, we will introduce the factory method pattern represented here by shape factory that will be responsible for producing these objects by removing such responsibility from the client app code. 4. Coding example.
Hey guys, so it's time for coding. So here we have our repository, design patterns examples. We'll navigate to src, main Java, creational group of patterns, and factory. And we'll start out of our diagram with the interface shape. This interface will have only one method called draw. Okay? So for the interface, we need to implement the concrete classes. So in this case, we'll go back to the project view and we'll start creating our very first concrete class. Let's start with the rectangle. The rectangle obviously will implement interface shape. In order to implement this interface, we need to override the draw method. So here we are. This method will basically just print that this is a rectangle. Okay, here we go. So the next one that we'll need to implement is the square. We'll implement the shape interface and we need to override the public void draw. Yeah, this one here will say that this is a square. Okay, and the last but not the least, we'll create the circle. So the circle also implements the shape. To implement the shape, we need to override our method draw, which for this case will say this is a circle. Okay, here we are. So now we have all the concrete implementations of our interface shape, which gives us all the means to create our own objects, right? In order to represent this as a client, let's create a client here, which will be represented by a new class called shape client app. Okay, this one will have basically a main method to be represented as the application. And here's the trick. When this client wants to build a new object, it will be necessary to specify the concrete classes. So we'll need to do something like this. Or if you want to create a square, you'll need to create a square like this. Or a circle, and so on and so forth. Okay. One way to improve this is by using the interface. However, still, you'll be required to specify the concrete class. the concrete implementation. Why this is not good and why this is good? Well, you've seen this in the previous section, but here from the code you can clearly see that if I want to create a different one, I need to come here and change my code. So I need to specify the circle, or I need to specify the square, right? The factory comes in hand to make it easier and to reduce the amount of code changes required whenever a different type will be needed. And here, for each case, and to make sure that they are working properly, we can call the draw method each one. Okay, draw method and draw method. Also for the shape, make sure that we'll have this as a square. So let's run it. Okay, so you see the first one rectangle, the second one a square, and the third one a circle. As using the interface, we have also the proper object creation here. Okay, so now it's time to introduce the factory method pattern, right? Good. So first thing we'll do is to come back project view and we'll create a class called shape factory. This class will have a static method that will return shape, which will be called produce shape. We could here pass a string to be evaluated in order to decide the concrete implementation, the type of shape that we want to produce, but let's do it slightly better. Let's create a shape type enum. In order to do that, we'll go back to the project view and create here the enum shape type. Okay, this will have rectangle, circle, and square. So going back to the factory, in order to make the decision, we'll use here just a simple switch case, where we'll pass the shape type, case rectangle, then we'll return a new rectangle. In case of square, we'll return a new square, and in case of circle, it will return a new circle. As a default creation or a default result, we'll return, okay, let's return null here. Let's go back to our shape client app, and here, instead of doing all of this, we'll now start producing shapes via factory. Nice, okay, good. So how we'll do that? We'll simply call the shape and shape produced, calling the shape factory produce shape, and passing here the shape type and enum value. Let's say we want the rectangle, right? Shape produced draw. Okay, so we can execute this and see what will happen. Here you see, start producing shapes via factory, and the shape that we produced is a rectangle. Okay, but what if I want to create a circle? Fair enough. You no longer need to change the implementation that you're calling, but you simply will change the value input that you are passing to the factory in order to decide and produce the concrete object that you wish. We can even go further. Let's say that in given case, shape type array shapes that our application is receiving, and for each shared type from shapes, we will produce shape object from our shape factory produce type. So what we are doing here is that for each type passed, creating an object based on the concrete implementation and asking this object to draw itself, print the message. So here we can actually this, and let's make it like that, running. Here we are. We could even do it like this to make it explicit, producing new shape object as a in the format. Okay, and import static, and here we are. So for each one, you will see the message with the respective type being produced. You see? That's it.
And 5. Interview questions.
Okay, so here comes the first question. What is the factory design pattern?
The factory design pattern is a creational design pattern that is used to abstract the process of creating objects. The pattern defines an interface for creating an object, but it leaves the details of the implementation up to the subclasses. This allows for new objects to be created without the need to hard code their specific class.
So the second question, when should we use the factory design pattern?
The factory design pattern is most useful when you need to create objects that are of the same type but with different data. For example, if you were creating a game with different levels, you could use the factory design pattern to create objects that represent each level. The factory design pattern is also useful when you want to hide the details of object creation from the user.
The third question. What are some examples of when you would use the factory method?
The factory method is used when you want to create an object, but you don't know ahead of time what type of object you will need. For example, if you were creating a program that could read in different types of files, you might use a factory method to create the appropriate object to read in the file based on its type.
And the fourth question, can you give a real example where I might apply the factory method to my code?
The factory pattern is often used in situations where you need to create objects that belong to a particular class, but you don't know ahead of time which class that will be. For example, if you were writing a program that needed to generate different types of reports based on user input, you could use the factory pattern to create the appropriate report object based on the user's selection.
The fifth and tricky one, what do you understand by the differences between static, abstract, and dynamic factories?
Static factories are the simplest type of factory, and they simply return a new instance of a class. Abstract factories are a bit more complex, and they return an instance of a class that is determined by the input parameters. Dynamic factories are the most complex, and they return an instance of a class that is determined at runtime based on the input parameters.
Sixth, are there any drawbacks by using the factory method? And if yes, can you please explain them?
Yes, there are some drawbacks to using the factory design pattern. One such drawback is that it can lead to code that is difficult to maintain and understand. This is because the factory pattern can often lead to a large amount of code duplication. Additionally, the factory pattern can sometimes be an overkill solution to a problem that could be solved more simply.
And seventh, this one in particular, it commonly appears in interview sessions. So here it goes. What is the difference between the factory and the builder pattern?
Think of the factory as a way to build polymorphic types, unknown types, or simply the ones you do not care, while the builder pattern is more about building complex objects, but not necessary polymorphic ones.
Hi guys, that's the end of today's video. I really hope it helped to clarify this particular topic, and please let us know in the comments right below if you have any questions, any ideas or suggestions for us to implement along the series. Thanks all and happy coding!
And stay tuned.